Hi, this is question 2 of the adjustment chapter of the regression models book. This asks us to look at this data set that we've been looking at for the last couple of chapters, the seatbelt data set in the exercises. And the first question simply asks us to repeat the exercise in case those are coming into this chapter without having done the previous ones. However, question 2 and 3 asks us to basically look at the topic of adjustment. In this question, question 2, it asks us to look at we're interested in the kilometers coefficient, and we're interested in what effect the petrol price has on the kilometers coefficient. So first, refer back to the previous questions on this to look at the data processing that we've looked at and some of these other things. So first, just as a reminder, we need to load the data set, library data sets, and then data seatbelts, and then we want to do seatbelts maybe with a lowercase s is as.data.frame seatbelts. And then we showed in dplyr creating a couple of variables that are very useful: normalized petrol price, normalized by centering it and dividing by its standard deviation, and the converting the kilometers into 1,000 kilometer units, and then also centering it. So let's do those. And then let's fit two models. First, let's fit model 0, which just has the kilometers data in it. And then let's fit model 1 that has the kilometers data in it plus this petrol price. Before we do that, though, it would be nice to see what the correlation is between the kilometers and the petrol price, just because that tells us a little bit of something about how much redundant linear information is contained in the two variables. It's at 0.38, so at some level these are measuring similar things, and it would stand to reason that the price of gas would have an impact on the total miles being driven. So let's fit both models, and let's look at summary, fit 0, grab the coefficient table, and summary, fit 1, grab the coefficient table. So what we see is that the estimate in this case goes down, something we would likely expect since both effects are in the same direction and they're correlated. So this MMC, which is the kilometers in 1,000 kilometer units centered, it goes from an estimated negative 2.7 additional deaths per every 1,000 extra kilometers driven per month to 1.7, so down by 1, and after the inclusion of the petrol price. So petrol price is having a confounding effect on the relationship between the kilometers driven and the number of drivers' deaths. Now, it hasn't changed significance. The significance did go down. It went from a p-value that's on the order of 10 to the minus 6th to a p-value that is on the order of 10 to the minus 3. However, in both cases, they're still quite significant. T-value from minus 4 to minus 3. Okay, and one last thing, I would just show you that you can do the ANOVA function with fit 0 and fit 1 and look at the testing for the effect of whether or not the petrol price is necessary. In this case, because it's just one variable, it should agree exactly with the p-value from the coefficient table. So here's the p-value from the coefficient table. It's about 2.3 times 10 to the minus 5, and here it is as well. Okay, so now what I'd like you to do is repeat this exercise in exercise 3, where we do the reverse, looking at petrol price and seeing the effect that the inclusion or exclusion of the kilometers driven variable has on it. Again, with the focus towards how does it impact my estimate of the thing that I'm interested in, with its inclusion or exclusion. Also do this in this exercise, maybe look at some of the other variables and how they impact things, whether or not the law or the law variable, for example, changes the impact that the kilometers driven has on the number of driver deaths.